All right, we've got the top of the hour, so we're going to get started. I'd like to welcome everyone to our webinar. I hope you're all having a good day so far. The focus of this presentation is on ways to build recreational trails for walking, horse riding, and light vehicle use, as well as different methods for stabilizing embankments near trails. I'm your host, Corey Schneider, a business development manager with Presto Geosystems. I've been with Presto for 19 years, providing technical assistance and site support for our entire product line. We are located in Wisconsin and manufacture erosion control, stormwater management, and porous pavement products that are used all over the U.S. and the world. We sell through an experienced distribution network that can provide local assistance on all of your projects. I have everyone muted now, so if you have questions during the presentation, please type them in the question window and I will answer them at the end. Here are the things I hope you get out of today's presentation. Understand how to properly build trails to reduce the impact to the surroundings, how different trail uses can affect the design, how to build through wetlands or other environmentally sensitive areas, and which products are most applicable for unique conditions that may be encountered. We are also going to touch on wall and slope design to ensure that embankments along trails remain stable. First, a little background on Presto. We worked with the Army Corps of Engineers to develop Geocell technology in the late 70s and have been innovating ever since. Our products have been used in nearly 200 countries and in every state in the US. We go beyond simply manufacturing and selling products. You can find a lot of design and construction resources on our website, which is prestogeo.com. We do have experienced engineers on staff that provide free project evaluations. You simply have to go to our website, fill out a short form, and within a couple business days, we will get you a recommended cross-section and calculations. We do also provide contractor support. So if you decide to use any of our products, either Presto or one of our distributors can be on site to make sure that the product is not only being installed correctly, but also as efficiently as possible. And as I just mentioned, we do sell through distribution network, and we can have them provide some local support at the beginning of your project. Presto operates in 3 product areas: soil stabilization using our GEOWEB Geocells, which can be used for load support, slope and channel protection, and constructing green retaining walls. Porous pavements, of which we have both vegetated and aggregate solutions, and lightweight reusable construction mats. Today, we will cover some GEOWEB solutions, as well as our aggregate porous pavement product and a few of our construction mats. An important thing to keep in mind as we go through this webinar, the trails that are made with our products are all considered permeable trails. That is, there's no impermeable paved surface being placed. The final surface is going to be a stone or sand material. This lessens the environmental impact of the trail, reduces the amount of heavy equipment required for installation, often in difficult to reach locations, and improves the overall cost and speed of the project. We'll begin with what makes a good trail. The first aspect of the design is the reinforcement of the trail area. Especially when the trail moves through sensitive areas, keeping the path intact is how you keep people away from damaging vegetation or getting lost while wandering. The trail needs to be clearly delineated and needs to be reinforced enough to stay in place over time. Using products specially designed to act as the reinforcement of the soil or stone means the trail will last longer and will not encroach on the surrounding environment. The next key to a well-designed trail is drainage. Ponding water can ruin a trail surface, and water that runs off the trail into unreinforced areas can scour and damage those areas. As I mentioned, all the products from Presto are considered permeable, and it is precisely for this reason. By keeping the surface permeable, the water infiltrates at the point of contact right when it hits the trail. The water can then permeate down through the product and into the subgrade, entering the groundwater system. The water won't pond at the surface, and it won't run off or collect outside the reinforced areas. This keeps the trail in the same condition, no matter the weather, so there won't be any flaws or failures created below the surface that you can't see. The last thing to consider when designing a trail is how to confine the surface. Loose aggregate, stone, or sand is easily moved under shoes, hooves, tires, and water, leading to ruts, holes, and generally damaged trail areas. When the trail surface is damaged, people are going to want to move around the damage, leading them off the trail and into unprotected areas, potentially disturbing sensitive environments. Keeping the surface in place is an important feature of the products from Presto. When the stone or sand is properly held in place, ruts cannot form and the material can't be washed away. This greatly reduces the amount of maintenance required because the trail surfaces aren't degrading. The first product we'll look at is the GEOWEB 3-dimensional soil confinement system. This is a geocell, which may be a term you have heard before. It is similar to a geogrid, but is 3-dimensional, so it has depth to provide true confinement and can be used in a wider variety of applications. GEOWEB system consists of two main components, cell size and cell depth. The cells come in three sizes, roughly 8 inches by 10 inches, 11 inches by 12 inches, and 18 inches by 20 inches. And heights of 3, 4, 6, 8, and 12 inches. The combination of cell size and depth depend on the project details and loading requirements, but generally trails will use a 4 or 6 inch depth and a small or medium-sized cell. Seam strength is very important to the function of a geocell. The stronger the seam strength, the better designed the geocell is. A strong seam allows for heavier infill material, steeper and taller slopes, and better lifetime performance. The strength of the panel material, in our case high-density polyethylene, is also critical to the strength and performance of a geocell system. Here you can see a typical GEOWEB panel. It comes tri-folded and palletized. Each section has a nominal width of 8.5 feet, with lengths varying between 12 and 58 feet. The panels are flexible, opening like an accordion, so they can follow the natural contours of the work site without being confined to a rigid set of dimensions. The panels can also be easily field cut to fit whatever project dimensions you require. GEOWEB and our accessories are 100% made in the USA under strict quality assurance and environmental control processes, sure to comply with all requirements for Build America, Buy America and the Infrastructure Investment and Jobs Act. The GEOWEB system is a 3-dimensional cellular confinement system, meaning that the GEOWEB panels have individual cells that are filled with an infill material that ultimately makes the final surface of the trail. By confining the infill material, the system distributes the loads and prevents rutting, and the cells keep the infill in place so that it doesn't wash away from stormwater runoff or move with traffic. The surface of the trail is going to be stable no matter what infill is chosen and require very minimal maintenance for the lifetime of the project. Let's look at some different options for building stable trails with the GEOWEB system. Walk, run, cycle trails are meant for people, small animals such as dogs, and bicycles only. This type of trail is typically not meant for equestrian use. These are the most common types of trails and can go along shorelines, through urban areas, or through forests or parks. The flexibility of the GEOWEB panels allows for smooth, natural-looking curves. The panels can be held open with stakes, as shown here, but those stakes are generally not permanent. They can be removed once the panels are fully filled. The panels can be laid either along the length or width of the trail. They are easily field cut with a saw or landscape shears and are securely attached together. No matter the dimensions, there will be little waste as panels can be pieced together in nearly any configuration. This is the finished trail surface using a local granite aggregate and allowing vegetation on both sides. The trail is clearly delineated and meets up with existing paved trails in the distance. The GEOWEB panels will keep the trail in place and level, minimizing surface erosion and potential runoff of contaminants into the adjacent waterways. This path used granite, but any type of stone is going to be acceptable as an infill material, with the only limitations being it should be angular and have a maximum particle size of about 1/3 the cell depth. So you can use what is local to your area without needing to truck in expensive engineered aggregates. As I said, it is easy to field cut the GEOWEB panels to accommodate the trail dimensions, even rather narrow trails like this one between a road and protected wetlands. By having the GEOWEB panels create the trail, water runoff from the road won't wash dirt into the wetlands because the water will be able to infiltrate through the permeable GEOWEB surface, keeping the dirt surface in place for a nice jogging path. Paths through neighborhoods or urban areas can augment or replace traditional sidewalks in places where drainage is a concern. Replacing broken and ugly concrete sidewalks with gravel surface paths allows for flexibility in design and aesthetic and will improve the safety of the walkway for pedestrians. These types of trails are good for any typical sidewalk traffic, but can also be designed to support cars or trucks. A 3 or 4 man crew can install about 1,500 square feet of GEOWEB panels per hour, including laying a geotextile fabric and infilling the panels. The geotextile helps create a separation layer between the natural subgrade and the infill material, especially important in areas of very soft subgrade such as wet clay. The flexible nature of the GEOWEB panels allows it to conform to hills and dips in the paths, and allows the system to be pitched to one side if needed. Because GEOWEB gives additional strength to the infill material through confinement, cross sections can be cut in half or more, reducing excavation, aggregate, and maintenance costs. We recommend overfilling the GEOWEB panels slightly when installing so that there is a wear surface over the panels and the plastic is not visible. This surface will become naturally compacted over time based on the trail usage. Having the panels slightly overfilled helps protect the GEOWEB material from vehicle tires or other potential damage. Equestrian trails are next, and they have some different requirements than walking paths. Equestrian trails have to be hardy enough to stand up to horseshoes while remaining smooth enough to avoid damaging their hooves. Horseshoes can pick up a surprising amount of dirt with each step, and with their heavy concentrated point loading can cause quick deterioration of the trail. If the trail is designed to withstand horse traffic, it is more than sufficient to handle hiking, biking, and small motorized vehicles. A GEOWEB trail system was utilized for erosion control for these equestrian trails. The gravel surface is resistant to rutting, and the 1-inch stone size is easy for the horses to walk over. This aggregate path will not get muddy or create sinkholes, so the surface will remain ready for use even after rain or heavy use. Having a well-defined path also helps prevent damage to areas off the trail, and using the GEOWEB system allows for inclusion of natural markers, such as the large boulders we see here on both sides of the trail. Now we're going to walk through a case study for a shoreline trail in the Colony, Texas. This project was a multi-use trail along the shoreline of a lake. The trail will see pedestrians, bikes, small vehicles, and potentially equestrian traffic. The client, the city of the Colony, wanted to follow the natural contours of the shoreline, which the flexible GEOWEB panels could easily handle. There was a concern about the potential for uplift under the system due to the very high water table and lake level fluctuations. so additional steps were taken to prevent this from occurring. A series of polyester tendons were run through the GEOWEB panels and were anchored multiple times per panel. The tendons, in conjunction with the final infill stone material, prevent the GEOWEB system from lifting and deforming due to groundwater pressures. This is a good practice in wet environments with potentially saturated soils. A well-graded decomposed granite was chosen as the infill material as it was readily available in the area. Using local materials is encouraged, though any type of stone is acceptable, again, as long as it is angular and allows good drainage. This means that you're going to want stone with limited fines so that water can percolate through. If the water can't infiltrate, you will get ponding at the surface, similar to a paved surface such as asphalt, so you want to make sure your infill material avoids this problem. And you should keep in mind that this material is going to be your final surface, so aesthetics may be a factor in choosing the infill. Once the GEOWEB panels were installed, the infill was placed with a standard front end loader and then raked by hand to ensure all the cells were completely filled. The material should be placed on the outside of the panels as needed to match the final grade and meet up with the unexcavated areas. For ease of construction, you can drive your vehicles and equipment on the GEOWEB panels as soon as they are filled, right up to the limits of the filled area if necessary, so you don't have to wait for the entire system to be filled before using it. This can help minimize the impact of construction on the area, since you won't need to create access lanes or clear out excess vegetation on the sides. A small smooth-barreled roller compactor finishes off the job. This is where having the wearing surface of overfilled material mentioned earlier comes into play. The compactor isn't driving directly on the GEOWEB panels, and you can easily visually confirm that no cell is underfilled. Again, the stone infill should have minimal fines, less than 10% is ideal. Avoiding fines in your stone allows the system to stay permeable and not get clogged. Trails built with the GEOWEB system are a great example of green infrastructure by not disrupting the water cycle or impacting the groundwater flow. No additional stormwater infrastructure is needed when the trail surface is permeable, so there is minimal impact on the environment around the trail. Here we can see the nice clean trail created using GEOWEB, allowing for most uses without having to worry about needing constant maintenance. The path is clearly delineated while maintaining a natural look that people won't mind seeing in their backyards. A few months after installation, there was a massive rainfall event, over 7 inches in a 3-hour period, which can be incredibly damaging both during and after the storm. Several portions of the trail were flooded to the point of standing water at the surface on and around the GEOWEB protected areas. But thanks to the GEOWEB system and the extra precautions such as the tendon anchorage, the trail is not washed away as you might expect from an unprotected gravel trail. The trail was still usable, allowing maintenance workers access to the damaged areas for inspection and repair. No repair was needed to the GEOWEB system, and once the water was able to infiltrate, the trail was as good as new. When there is such a large rainfall event, the ground becomes saturated and doesn't allow water to infiltrate, giving it no choice but to stay at the surface and become sheet runoff. The GEOWEB system protects the trail surface against erosion when this happens, with the cell walls functioning as a series of check dams, keeping the infill confined within the individual cells. Then, when it is able, the water can infiltrate into the ground and the trail is still in good shape. In the spring of 2018, several storms violently swept through areas along southern Maine's coastline, devastating the beaches and trails of Fort Foster, a town-owned park in Maine. As you can see from these photos, the trails and maintenance roads were washed out. To reconstruct the washed out recreational trail and maintenance road, 6-inch deep GEOWEB panels were installed at the site and infilled with a 1-inch crushed aggregate. There were sections of the trails that sloped down to the beach areas. To stabilize the 2-to-1 sloped areas down to the beaches, 4-inch depth GEOWEB sections were secured to the face of the slope, a dead man tendons and atra tendon clips. Then the GEOWEB was filled with aggregate and covered with large riprap. By using the GEOWEB system, the park was able to armor the maintenance road, recreational trail, and slopes from future storm events. Here's a before and after photo of one of the trails. Since its original installation in 2018, the GEOWEB load support and shoreline protection system continues to perform as designed, allowing the community to once again enjoy the trail system and local beaches. The existing causeway on this project, which was used as a walking and biking trail across Lake Champlain, was blown out due to storms and had to be closed. The local distributor worked with the town and submitted a request for project evaluation through our website. Here you can see Presto's recommendation of the mid-size cell, 4 inches deep. Installation took place in November of 2019, and the trail is holding up well after several significant storm events. One of the biggest questions we get is about cost, especially if this is a new technology for you or your area. Having an idea of how much the GEOWEB system costs compared to other stabilization techniques is very important. So here we have a basic comparison for the GEOWEB system for a load support application, in this case, a gravel surface road. This comparison shows the difference in both price and cross-section depth for an aggregate-only unreinforced section, a section using geogrids and geotextiles, and then 2 sections showing the use of the GEOWEB system, one with aggregate and one with salvaged on-site materials as the infill. You can see the GEOWEB system is both thinner and less expensive than the other methods, significantly so when on-site material is utilized. In fact, a 50% savings can be realized compared to the geogrid and geotextile section, which does not allow for the use of most salvaged or on-site material, as high friction angle, well-graded material is required with the use of grids and textiles. Of course, your aggregate costs and distance to quarries may vary, but this will give you a general idea of the savings that can be achieved. Now, moving away from the GEOWEB system. This next option illustrates similar confinement of infill, but within a rigid paver structure, our GeoPave. Unlike the GEOWEB material, which is typically 3 or 4 inches deep for trails, GeoPave units are 2 inches deep and made from recycled high-density polyethylene. The GeoPave units have these rigid paver characteristics with specific features needed for performance with aggregate infill. The main one I want to highlight, though, is the monolithic mesh bottom. This is a molded in-place mesh on the underside of the paver unit. This mesh keeps the stone infill from migrating under the unit, and the integrated nature assists in the overall rigidity of the paver unit. The lattice bottom spreads the load similar to a snowshoe so that wheel loads do not create ruts. GeoPave units are locked together with a connection device to create a fully integrated contiguous pavement that is highly resistant to traffic stresses. GeoPave was designed using a finite element analysis and will not lift up over time as seen with other systems. As I mentioned, the GeoPave unit is only 2 inches deep, which can be a real asset if the project requires a thin cross section due to buried utilities or high excavation costs. We'll now look at a few GeoPave project examples. This project is an access trail for walking down to a swimming area on a lake. The walkway had to be ADA compliant so that everyone could use it. It was also important that the trail help reduce runoff into the lake, so the permeable nature of the GeoPave system was critical. You can see the eroded trail before stabilization, both the trail surface and the surrounding areas, and the new trail area on the right stabilized with GeoPave. The protected system will help prevent erosion from stormwater runoff and be a smoother surface for walking on for visitors. This is another trail in a wetland area this time. Here, the GeoPave units were placed directly on the subgrade, but a geotextile separation fabric and a base layer of aggregate underneath the panels can be incorporated to support heavier loads or add additional detention. No matter the section, the entire system creates a flat, stable surface and supports anticipated loads. The same principles that we discussed with the GEOWEB system apply here as well. By using an open graded aggregate stone with minimal fine content, the water can infiltrate at the point of contact, reducing surface runoff, and the individual cells confine the aggregate, preventing rutting and washout of the stone for a stable walking surface. A major concern here was protecting sensitive tree roots from impact damage. The GeoPave units are a great way to provide tree root protection by creating a bridge over the roots, so there is no direct contact from vehicle or pedestrian loads that could harm the trees. This bridge lasts the lifetime of the GeoPave trail and allows the trees to grow unimpeded. One of the great things about building trails with the GeoWeb or GeoPave system is the amount of choice you have over the final look of the system. 2 rock colors were chosen at this site to delineate the parking from the walkways. A light colored crushed limestone was used for the parking areas, and a contrasting reddish brown buckshot crushed aggregate for the walkways. Additional delineation, such as concrete parking stops or snap delineators, can be included to help create a sense of separation within the overall GeoPave system. The project ultimately earned LEED Gold for all of the low impact structure and landscape elements. Protecting the local watershed was the primary reason for the inclusion of permeable parking and walkways utilizing the GeoPave system. These pavements also perform as natural on-site stormwater detention, storing water in the base for natural percolation without the need for a large isolated detention pond, which would have been an unattractive nuisance on site. The GeoPave units come in 20-inch by 40-inch panels covering about 5.4 square feet, but they can easily be field cut or staggered to accommodate curves, so you're not locked into a linear path. The system was a great choice for this project with a quick and easy installation, the ability to allow water to flow through the system and not run off into the pond, and providing a smooth, clean surface for walking. The standard GeoPave units are black, but a tan GeoPave is an option that allows natural blending with light colored stone. Again, the options available for the final design of the trails are what make using this system so versatile and a great choice for any project. The last option for trail surfaces is the GeoTerra system, which are construction mats that are strong yet lightweight and don't require any fill. Because no fill is required, they are perfect for areas where infill resources are scarce. Because there's no fill material, GeoTerra trails won't kill the existing vegetation they are placed over. They are open on the top and bottom and allow for vegetation to grow through them for as long as they are in place, which is essential for minimizing environmental impacts for pathways. GeoTerra units cover approximately 5 square feet each and can be connected to cover a larger area as needed. The mats are strong enough to support heavy vehicle and construction traffic loads and have enough flexural strength to bridge soft soils without warping or cracking. GeoTerra units are connected with strong metal connectors to essentially form a floating road through wetlands with very soft soils. The connected mat system distributes loading across the pavement, minimizing potential for rutting or sinking in soft, muddy soils. In some areas of Alaska, hundreds of miles of ATV trails cut across wetlands and stream beds, causing extensive damage to natural preserves. ATV riders can cause the loss of vegetative cover and habitat values. GeoTerra mats offer a great solution for low impact access in these wet and environmentally sensitive areas. The preferred method is to place the units across the entire trail width, but in some cases, just in the wheel paths is acceptable. As planned, indigenous grasses regenerated through the permeable open-celled GeoTerra mats, ultimately semi-camouflaging the product with the natural environment and protecting the vegetation from damage. In this case, the system ultimately ended up as a permanent structure, and the GeoTerra mats will be able to last for as long as needed. The last section is going to pivot from the flat surface of the trail to the embankments that may be alongside or near the trail. Green walls can help create the space for trails to run through and work with permeable trails to allow water flow and promote vegetation. The same GEOWEB Geocell technology that creates the trail surface can also be adapted to create retaining walls, such as this vegetated levee. The GeoWEB panels are stacked vertically on top of one another to create the wall, allowing for more horizontal space for the trail to be placed. The primary benefit of the GeoWEB wall is to create a stable, natural living structure with vegetation for aesthetic appeal. The open front fascia allows rainwater to infiltrate, and the wall structure can also absorb some runoff from the top of the wall, such as from walking trails. While vegetated walls are most common, aggregate-filled walls are also possible. Using the same open graded aggregate we have been talking about, water can infiltrate through the wall so there isn't runoff onto your road or trail. An aggregate wall may be useful when you don't want to worry about maintaining vegetation in an area, such as an emergency response space or in areas where vegetation is difficult to establish. The walls are designed as either gravity or reinforced walls in the same way as mechanically stabilized earth or MSE wall systems. An advantage they have over MSE block walls is flexibility in poor soil conditions. Their relatively lightweight and flexible nature allows them to tolerate reasonable differential settlement very well. Another advantage over traditional walls, such as gabion baskets, is the relatively shallow embedment depth of the wall and the ability to create a very steep wall face up to about 80 degrees. It is always necessary to consider live and dead loads that the wall will experience, especially when placed near trails or roads. Dead loads can be buildings or soil slopes above the wall. Live loads are from construction traffic and long-term vehicle traffic. When possible, the load should be placed away from the edge of the wall or fascia. If not possible, the design will need to be robust enough to support and withstand the live and dead loads. Having traffic barriers at the top of the wall, such as this wooden fence, will help keep the loads away from the GeoWEB system, which can help with the design. We'll now look at a vegetated retaining wall case study. This project was faced with having to retain soils in a very problematic soft soil area, but piling systems were expensive and they wanted to maintain the natural environment. Concrete and modular block walls were considered, but ultimately they chose the vegetated geocell wall for its natural aesthetics and lower cost. Here you can see the wall structure is constructed with a slight setback to allow for topsoil fill and vegetation. The backfill material is a good drainable aggregate. The wall can be seeded either by mixing the seeds in the soil before installation or by hydroseeding or broadcasting once installation is complete. As mentioned, the system's inherent ability to withstand some differential settlement in soft soil environments was extremely important at this site. The wall had varying heights along its length, which was also easily accommodated by the Geocell system. By using the Geocell wall, they didn't have to bring in invasive equipment such as augers or H-piles, speeding the installation process. Here's the completely vegetated wall. The horizontal terraces allow rainwater collection, helping to minimize runoff and erosion. Pretty much any type of grass or flowering vegetation will survive on these walls, so by using local vegetation, upkeep can be kept to a minimum. Presto Geosystems offers a free software for designing GeoWeb retaining walls and slopes. It is available on our website, again, prestogeo.com, and can be used by engineers and designers to determine if the GeoWeb system is appropriate for your projects. There are a lot of resources on the website on how to use and interpret the software, but we are always happy to help with questions or recommendations. So far, we have looked at trail surface construction and vegetated retaining walls. GeoWeb can also be used for erosion protection in a superficial manner. This is a good way to protect slopes against erosion when the slope is shallower than what would be required for a retaining wall and globally stable, around 60 degrees or shallower generally. If there are questions about this type of application, we are happy to talk through it. There are three main infill types for slopes, depending on the type of protection needed: topsoil, aggregates or granular materials, and concrete. We will focus on topsoil and vegetation infill, as that is typically what is selected in trail applications to keep things looking as natural as possible. Here's a simplified diagram showing how the different system components interact with the GeoWeb to form a complete system. We'll talk about each of these components next. To begin, we have our slope with some standard dimensions. The first thing to go down is the geosynthetic layer, which can be a geotextile, geomembrane, geogrid, or any similar product. These aren't always required, and we typically try to stay away from them in vegetated applications, but we can make recommendations based on project details. Then the GeoWeb is put in place. Note how the GeoWeb has a horizontal turn near the top of the slope. This is important for crest anchorage and erosion control. We have two options for anchoring. One is using stakes or anchors. They are placed mid-slope, and at the crest, the number and spacing of stakes is project dependent. The other option is to use tendons and a dead man, with the dead man being a buried pipe, concrete anchor, or earth or rock anchors at the crest. The GeoWeb is then filled with the desired infill, and if vegetated, an erosion control blanket or hydroseeding is used until vegetation is established. The ATRA key is the first component for a completely integrated system, connecting each individual panel of GeoWeb into a single web that covers the slope. It allows for faster installation of the GeoWeb and will last the lifetime of the project, ensuring that the slope is protected and that the GeoWeb system will not fail under anticipated loads. The specific engineering values of the ATRA key will ensure the system holds up to the loading over time, without the corrosion seen in staples or the failure of underperforming cable tie systems. As slope angle increases, the driving force of the infill material exceeds the available frictional resisting force, and additional anchorage is required. The ATRA anchors, which are our ATRA stake clips on top of number 4 rebar, hold the GeoWeb to the slope and penetrate into the ground. If corrosion resistance is required due to project conditions, Presto has a HDPE ATRA speed stake that is designed to work with the GEOWEB. For long, steep slopes, slopes where the native soil is highly erodible, or over a surface that cannot be punctured, such as a liner, tendons can be used. The ATRA tendon clips transfer the load from heavy infill material to the tendons and crest anchorage system. Only the ATRA tendon clip is specifically designed to fully transfer safely and securely the forces placed upon the geocell. Every accessory and every feature has been designed and tested to specifically work together so that we go from problem to design to construction solution with a system where the modeling replicates the real world forces. Now we'll take a quick look at a couple of slope protection projects associated with trails. The American Tobacco Trail is a 20-mile rails to trails project running from Durham County to Chatham County in North Carolina. This slope had to be reconstructed after it was excavated in conjunction with the replacement of a culvert. After the culvert was replaced, the slope was regraded to its original 1.3 to 1 slope, and it needed to be revegetated. The GEOWEB slope protection system proved to be the perfect solution. Another great example of using GEOWEB for slope protection on a trail is the Lance Armstrong Bikeway in downtown Austin, Texas. And you can see from this photo, many of the slopes are just hydroseeded or planted with grasses, but it is also possible to plant small shrubs into the individual GEOWEB cells. So your type of vegetation is not limited by the GEOWEB at all. In summary, Presto Geosystems offers GeoWeb, GeoPave, and GeoTerra that can meet any trail design needs, as well as GeoWeb for earth retention and slope protection near trails. Each product is designed to protect the surrounding environment while offering a low-maintenance surface that won't wash away during heavy rain events. We offer a complete solution, including connections and anchoring options. Part of our complete solution is our technical assistance. We provide free project design evaluations. The form is on our website. You can fill it out with as much information as you have, including attaching documents such as geotech reports, and it comes to us. And within 3 business days, but usually faster, we provide a complete design evaluation, including infill recommendations and anchorage requirements. We will work with you to get you the best design for your project. We deliver quality and over 40 years of expertise, guaranteeing each shipment meets or exceeds our specs so you can deliver certainty and build with materials you can trust. We have made it faster and easier for you to obtain your PDH certificates. With our webinar dashboard, you can easily view our library of webinars and download PDH certificates for on-demand webinars completed. Your webinar dashboard will keep a record of on-demand webinars completed along with PDHs earned. Please note that certificates for live webinars are managed separately from the on-demand webinar dashboard. So you won't find your certificate from today in there, but you will receive an email from GoToWebinar within the next 2 hours containing a download link to obtain your PDH certificate. In 2 to 3 days, you will also receive a separate email from Presto Geosystems with more information about accessing the on-demand webinar dashboard with other helpful resources. If you do not receive either of the previously mentioned emails, please check your spam folder. Here's my contact information. I do want to thank you for attending and remind you that you can send questions to us at any time at info@prestogeo.com or directly to me at the email listed here. Go to prestogeo.com for a wealth of information, and don't forget to view our YouTube videos found by clicking on the YouTube icon in the upper right corner of our webpage. I'll answer questions next, but if you do have questions that I don't get to, or you think of a question later, you can respond to the follow-up email and we will be happy to answer your questions and help with project recommendations. So now I'm going to scroll to the top and take each question. So the first one is, if larger planting areas are required mid-web, how do your products handle cutting voids into their centers to accommodate things like larger shrubs or trees? That is not a problem at all. You can certainly cut one or two cells to go around existing trees or to plant larger trees. I mean, you do want to avoid doing an outlandish amount of cutting because that would kind of defeat the purpose of the GEOWEB. But a large tree every 10, 15 feet or something like that is not an issue. Question, are there CEUs for landscape architects? I believe that landscape architects require a pre-approved course, in which case this would not qualify, but you can get your PDH and submit it to the organization and see if it works. How can hydrostatic uplift be a problem if the system is pervious? Well, that would just be if, the subgrade got super saturated and began to actually pump water. Then if you did not use the tendons, you might have an issue with long-term uplift. Let's see, where are we? Is it preferable to build the trails with a level surface, or can it be built with a cross slope or crown? Cross slope, crown, or level, any one of them works just fine. We don't really have a preference. Over time, do the cells in either system lose infill? My thought is that tripping hazards might be created by exposed GEOWEB and geopaved walls. They could potentially lose some infill, especially on sloped areas or after large rain events. My suggestion would just be to, certainly after those major storm events, just to take a quick tour of the trail. And if there are some areas where the cell walls are exposed, just do a little refilling of the units. What does the edge treatment look like for these systems? Yeah, you can use really any sort of edging that you would like. You actually aren't required to have any edging. You can just have it match up with its surrounding grade, and that works just fine as well. But any type of edging that you would like to use is going to work. What is the load bearing for the GeoTerra? That really depends on subgrade strength. So if we have a subgrade strength and a maximum load, we can determine if the GeoTerra will be appropriate. Can we use this option near railroad? Yes, you certainly can. Do you need to over excavate and then place any specific materials for subgrade? Again, completely depends on subgrade strength and maximum loading, but we can run calculations to determine if a subgrade is needed or if a base layer is needed based on those inputs. Your photos show examples of projects that do not have defined edges. Is it more common to keep the edges more natural, or how do you account for long-term maintenance as vegetation grows over? Again, if you prefer to have edging, you're more than welcome to use it. Many people don't because they try to keep it as natural looking as possible. As vegetation grows over it, you just have to go out there with a weed whacker and eliminate the vegetation. Do you have examples of using your products in a ravine situation where the goal is to reduce erosion without disturbing existing conditions? Yes, we can certainly provide you with that. If you'd like to send me a separate email, I can get you some examples. Can this be used on top of levees? Yes. I've got someone who's curious how the various webbing components made from plastic interact with the earth environment over time. There are no microplastics associated with HDPE, so that is not an issue. And being made out of plastic, they don't even begin to break down for over 100 years. What's the best product to use if the project is built on a topsoil layer over a high water table and the final surface is planned to be asphalt? And what would that typical section look like? Once again, if you're going to put asphalt over the top, GEOWEB is definitely the way to go. GeoPave is not used for base stabilization, but only for the surface. And the section would depend on subgrade strength and maximum loading. How do you keep the surface course of aggregate from becoming eroded and impermeable over years of driving on the surface? Well, you do need to maintain these if you want to maintain your permeability. We certainly recommend using a leaf blower when anytime that any of these surfaces become covered with leaves and other organic debris. As long as we can keep the organics off it reasonably well, then the permeability will last. Question about examples of using your products in cities and high urban density. We do have some examples. Again, if you want to send me an email directly, I can find some for you. Can oil and gas infiltration through permeable roadways cause groundwater pollution issues? Yes, certainly can. We want to avoid leaking oil and gasoline on anything permeable, without a doubt. Is there a maximum slope that this can be used on for roads? Really, I would say it depends on the type of traffic that we are looking at. Again, a lot of these are more project specific questions where there isn't really a general answer. For systems over tree roots, I'm assuming the tree roots will start to raise the trail in those locations. What type of maintenance is required in this condition? Well, I mean, there isn't really much you can do if you are concerned. If you want to save the tree, you have to let the tree roots lift the system, and you just have to live with it. Unfortunately, there's not really a way to prevent tree roots from lifting the system without damaging the tree. Does the tan colored GeoWeb material offer the same UV as the black? Yes, we just put a different UV inhibitor in there. And yes, UV protection is over 100 years, regardless of the color. For infill above the GeoWeb layer, what depth is recommended? Really just an inch or two. The whole idea is just to protect the top surface of these cell walls long term. So any coverage is really all you need. All right, that looks to be all the questions. And we're bumping up to the top of the hour, so we will end the webinar now. Hope everybody found it informative and useful, and please join us on other webinars in the future.